Okay, now that we've tested and made sure that our Arduino kit or Arduino Uno is working and we can upload a sketch to the Arduino, let's work on our first circuit and our first code that's actually going to do something. And this lesson is going to be more about defining how to set up a circuit and how to define variables and then different things inside the IDE, more so than trying to accomplish anything specific. So I have this open in Tinkercad, and just to show you this software, uh, I have a Arduino Uno. I've connected the digital pin 9 to a breadboard. Again, keep in mind these breadboards attach, or the pins inside this breadboards, the sockets, attach along each of these rows, and it highlights those inside the system, as well as along these plus and minus columns, although I'm not using those. I've got a red LED, a 100 ohm resistor, and that's going back to ground. So this circuit basically goes from 9 to the anode on the LED, to the resistor, back down to the ground. And what it's going to do is I'm going to turn this LED on or off by setting the state of the output on pin 9. And in this code, which is what we're going to do here, all I'm doing is defining pin 9 as the red LED pin. So I have an integer, that's what this int stands for. And we're saying that's red LED pin, that's the name of the variable, and it's equal to 9. So anywhere you see red LED pin, really you could just replace with 9. I'm setting the pin mode, basically the format for the pin 9 as an output. So the red LED pin, which is 9, as an output. I'm writing this as high, which means it's going to turn that on. Then I'm just waiting for a second. Even though I don't really need to do that, it does help with the simulation because it has to have a cycle time. So when I run this, it turns this on. And you can see it plugs it in, shows that it's powered, and the LED turns on. One of the nice things about this Tinkercad software is that I set this resistance here to 100 ohms. And you can see what happens if I lower this down to 10 ohms or 1 ohm, we should see that the LED has a different current going through it, right? And you actually see this one here. It says the current through the LED is 52.6 milliamps, right? And probably what is going to happen if I were to build this circuit with this 1 ohm resistor is you would burn out this LED because it's not able to handle that much current. So if I bring this back up, I can say, well, what about 10 ohms? Right, okay, now it's at 45 milliamps. So again, probably still not good. 100 ohms, now we're down to, it actually doesn't have the drop up anymore, so now it's no longer giving me that error saying the resistance here. So let's look at this, what it looks like in our physical circuit, and then we'll actually code this into our IDE, and we'll run it and make sure that we're able to get it to work. So here we have our physical board, our Uno, and just like in the simulation, we want to connect the pin 9, the digital pin 9 on our Uno to our LED, and we're going to do that through the breadboard. So I'm going to find pin 9. Again, you can see the numbers for each of the pins on the side of the board here. So this is 8, 9, 10. Hopefully that's a little easier for you to see on your actual board, but I'll plug that into the socket next to pin 9. And then I'm going to take this over to one of the rows on my breadboard, and I'll just plug that in. Now your LEDs have two wires, right? They have an anode and a cathode, basically a positive and a negative side. And the reason they have this, because it's an LED, it is a light emitting diode. So the diodes only allow current to pass through in one direction. So basically the positive side, right? If you're going to power it, always has to be the longer side. That's the anode. So if I want to plug this in, I want to make sure that the positive voltage is going to go into that longer terminal. And so I'm going to plug this in so that way the LED, the positive side, is on uh, the same row as my red jumper there. And it's a little hard to see inside the video, but you can see that those are on the same row. And so that's going to connect that anode to this red wire. Now I have my resistor, and again, I know this is a 100 ohm resistor for a couple of reasons. First of all, on the packaging, it says it's 100 ohms. So that's a pretty safe bet, right? Also, if I look at the LED itself, or the resistor itself, a little hard to see because my screen doesn't focus very well there that close. But if you look at it closely, you see there's a number of bands on it. And on this one, I have brown, black, 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 brown. So it's a 5-band code. And you can actually look up the translation for these, but each of these bands corresponds to a number. So brown is 1, black is 0, right? And then brown is also the tolerance. So this is a 5-band code. So I have 1, 0, 0, and then the multiplier here is 1. So 100 times 1, right? So that's 100, and then the tolerance is 1%. So this is a 100 ohm resistor with a 1% tolerance. On the Tinkercad, it actually is using the 4-band code. So it's brown, black, brown, gold. And so that would be a 3-band code. So 1, 0, 1. So 10 times 10 is 100. And then the gold is a plus or minus 5%, right? So the one I have here is actually a higher tolerance resistor than the 5% one. And again, this just allows you to figure out what the resistance of the resistor is without having to have any kind of documentation or look back to your kit here. So I want to take this resistor, I need to put it in line with the LED. It doesn't really matter if it comes before or after the LED, it's just there to control the amount of current going through it. So I'm going to go ahead and put it on there, on the cathode side, because I've already got my anode connected. Then actually I don't need to have a jumper going through the LEDs. The leads on the LED are actually long enough that I can have it go directly back to ground on my Arduino. So I'm just going to plug that into the ground socket. Right. So again, I'm going from my pin 9 socket to my breadboard. The breadboard connects the jumper to the anode on the LED. Then the cathode on the LED is connected to the resistor, again through, this is row 2 on my breadboard, and then that goes back to ground. So this is going to complete the circuit, and hopefully if I set this to 5 volts, which is a high, it'll turn the LED on. And then if I set it to a low, which is 0 volts, then there'll be no difference across it because the ground is at 0 volts, and it will be off. So I control whether or not this is on or off using my code. Now that I've got that built out, I can build in my code. And again, it's also important to note that I have this unplugged when doing this. You usually don't want to have anything plugged in while you're building the circuit. So I'm just going to leave that as it is. And then over here in my code, the first thing I'm going to do is going to define the global variables. So the global variables are defined outside of these functions. So I have this setup function and the loop function. The setup function is going to run once. The loop function is going to run continuously. But anything I define outside of those functions is going to be accessible to both of them. If you define something inside the function, it's only going to be available to things that are inside that function. So it's the difference between a global versus a private, or a public versus a private variable. So I'm going to set up an integer. That's what that int command stands for. And then I'm going to set up the red LED pin. That's the name of the integer, so that's the variable name. I'm going to set it equal to 9 because that's where I have my LED plugged in. I'm going to make a comment here using this double / saying that pin for red LED. It's always a good idea to put as much and as clear comments in your code, as well as to use variable names that are fairly obvious. If you use random letters or numbers, then it's not going to work out very well. Also, you need to make sure your variable names start with a letter. It's a good convention. Now in here, there's a comment on this blank set that says put your setup code here to run once. So it only runs once inside this code. And I only need to set the output for the pin once. So I'm going to say pin mode. And I know that this is a native function inside the Arduino code because it turned orange. So anything that turns orange, that's a reserved name. So if you're looking for something that exists or something that's already defined, like a function, then you know you got that function name correctly when it turns orange. If you're trying to name something, using a unique name, and it turns orange and you don't want to use a function, use a different name because you don't want to use those reserved functions as names inside your code. So I'm going to set the pin mode for the red LED pin. I'm going to set it as an output. Again, you see that turns blue because that is a defined variable. So that output is already defined as a set inside my thing. You'll also notice I'm putting a semicolon after the end of each of these lines. That semicolon tells the code that that line is done. right? And so it's not looking for anything else after that. If you don't put that semicolon there, it's going to keep looking for more text or more code after the end of that, and it's going to say, hey, wait, I didn't find anything more, but you didn't output it, and so it's going to complain to you that you haven't coded it properly. Again, we want to add comments here, so I'm going to make sure that I set this is sets the LED red pin as an output. And then the only way I need to do in this is I want to turn the LED on, right? So to turn the LED on, I need to do a digital write. Again, if I don't spell this right, it's going to let me know because it doesn't turn orange, right? So if you have a spelling error or something like that, check that. If you don't know what the names of the functions are, if you get what the names of the functions are, you can go to the reference, and the reference will give you a list of all of the functions that you can use, and this is a good way to figure out how to use things. Also, they usually give you examples of how to use these different functions in code. So, if you forget how to implement something, then that's a good thing to look at as well. So I'm in digital write. I'm going to copy and paste the red LED pin. I like using copy and paste using Control C and Control V as much as possible. This is going to prevent you from accidentally having a typo when you're typing in the name of a variable. I'm going to set this to high. Now, high, true, 1, all those things are basically the same in here, basically returning that output on. And this is all I really need to write, although this is going to run through this loop many, many, many times. And so to make it a little bit cleaner, a little bit easier, I'm going to add a short delay of 1 second or 1,000 milliseconds, right? So this one's going to turn the LED on. And then wait for 1 second before it goes through the loop again. I'm going to upload this. It's going to ask me to save this sketch. So I don't have this in a folder yet. So I'm actually going to put this in my let's just make a new folder for BEaM in this library. I'm just going to call this LED on. So I've saved the sketch. It's compiling it. After it finishes compiling, it's going to send the sketch or upload it to the Arduino. Oh, I don't have the Arduino plugged in. So again, going back to that first step we talked about, this is not going to work unless we actually have an Arduino plugged in. So I'm going to go ahead and take my LED or my USB cable. You see I got an error there because it wasn't plugged in. It couldn't send to upload it. I'm going to plug it in. I'm going to make sure I have my port set up and my board set to an Uno. And then I'm going to try and upload this again. You see my LED turns on. Right. It's a lot brighter inside the video here than it is in person, but you see it's on. It's really bright. Right. We can also go through and I can change this to low. If I upload it again, LED turns off. Right. So I can control the state of that LED programmatically inside this sketch, and we'll go over some more advanced functions in this in the next video.